welcome everybody. And I know we've got people actually from all over the world today. I think we've got some from Georgia, Ohio in the U.S. I'm in Maryland. We've got a class in Maryland. We've got Prague, the Czech Republic, excellent. Wisconsin in the U.S. I don't know, we had the Dominican Republic, Poland. So we've really got an excellent, wonderful world representation here. Thank you for joining in and for helping kick off our field campaign today. So are you all seeing my PowerPoint screen? Anybody? Yep. Okay. So I'm going to go through just a really short little bit of a presentation, but then really what I'd like to do, especially for those that have students, just to get a chance to answer some questions. So I'm going to tell you a little bit about the Global Precipitation Measurement Mission, and then we'll get some questions here. And if at any point, I think I muted everybody just for now, but if at any point you have a question, you can either type it in the chat window, or I'll try and stop and ask for questions, and you can unmute to ask questions, but just so we don't have any interference during the presentation. Okay, so actually here's the first question for you. So my name is Kristen Weaver. I'm an education specialist for the Global Precipitation Measurement Mission, and I work at NASA Goddard Space Flight Center in Maryland. So maybe if we can have, what do you think of when you see NASA, the NASA logo? What do you think of? Either maybe type a few thoughts. I see some hands up there in Mrs. Carey's class. Excellent. That's a good one. Innovation. It's great. Usually when I do this, I have mostly U.S. students. This is fun to have some people from all over to see what people outside of the U.S. think of when they think NASA, when they see NASA. Well, I'll let people keep putting those things if they want to add those comments. Oh, rockets, good. Going around in space, excellent. Well, those are some of the things. So usually people think of like astronauts, space shuttle maybe, stars, galaxies, planets. These are some of the answers that I often get. Pictures from space, great. But one of the kind of cool things is that I work for a mission that is studying this planet. And I'm sure if I were to ask Mrs. Carey's class or our students in the Dominican Republic, you all know, everybody knows what planet this is, right? The planet Earth. So we also need to study this planet, and that's really important, and that's what this satellite mission studies, is this planet, our lovely planet Earth, and specifically water and fresh water. So, you know, you can see this graph here that although, if we go back a minute, looks like the Earth has a lot of water on it. Look at all that beautiful blue, but unfortunately, not very much of it is actually useful to humans. So we've got just a little bit of water, 1% of that water on Earth that's actually available for us to be able to use. And if we break that down even further to that usable water, that little bit of water that we have, if we're looking at our atmospheric water precipitation and things that we're looking at, it's even smaller than that. So really, even though it seems like our planet Earth should have a lot of water on it, it actually, not very much of it is very accessible. So when we're thinking about the water cycle, and especially in our case, precipitation, that's what this satellite mission that you're going to be helping out with these ground observations is with, looking at this one part of the water cycle and looking at precipitation. And so it's really important to monitor that.
We plan our lives around rain. We always want to know when and where and how much. Not just for our weekend plans, but for how we make decisions about our safety and transportation, our economy, or our livelihoods. So, how do we measure rain? Well, we can set out a rain gauge, like this one, and it measures the amount of rain that falls over time. The problem with this is that it only measures rain in one very small spot. In fact, if you took all of the rain gauges in the world, packed them together, they would fit into 2 basketball courts. Now, we can cover more ground if we use radar. Radar sends out a signal, and it measures how much of that signal is scattered by rain or snow. But radars are only available in certain parts of the world, and many countries just don't have access to that technology. And that's just on land. Think about how we're going to measure rain over all of the world's oceans. Look, the point is it's impossible to cover the entire Earth with enough instruments that are going to give us accurate precipitation rates for the whole globe. So, we have to think bigger and higher. Instead of having a patchy network of rain gauges and radars, we could have a whole constellation of satellites looking down at the Earth, measuring things like falling rain, snow, and even ice. The Global Precipitation Measurement Mission, or GPM, is going to do that, and it's going to give us precipitation rates for the whole globe every 3 hours. Now, GPM is going to cover it all, from land and oceans, from the tropics to the edge of the poles, over mountains and valleys, from our farmland to our cities and towns. We're going to need more than a perspective on the ground if we're going to look at precipitation from a truly global standpoint. And GPM is just the mission that's going to give us that big picture.
But the basic idea is that rain gauges, we don't have enough rain gauges. You can see on the left that picture, all those gaps in between those yellow dots. That's places where we don't have official rain gauges. In fact, if we took all those rain gauges and put them in one place, they'd only actually fill up 2 basketball courts. So we really don't have as many rain gauges as we need to get a global picture. And even something like ground-based radar, there are still gaps in that coverage. As you can see, I mean, this is just the US, but you can see that it doesn't go out past the oceans. It just doesn't cover all of the Earth if we just rely on ground instruments, which is why we have to look from space. So we have the GPM Core Observatory that launched in February of last year, almost exactly a year ago, and it has 2 kind of primary instruments on it. It has a microwave imager that can give us rainfall totals. So you can see kind of where that arrow is pointing, those red areas. Those are areas that are getting heavy precipitation. And this is a typhoon from just earlier last month. Then it also has, what's really cool is these radars that are kind of on the bottom of the satellite. There's 2 boxes. You can't really see the second one very well in this particular picture, but that's giving us actually a 3-dimensional picture of the storm cloud, and you can actually see where all where it's heavy rain in the top of the cloud or the middle of the cloud or the bottom of the cloud. So with these instruments, we can start to figure out what's happening and how much precipitation is happening and what's going on. And so you can see this is some of the parts of the instrument. There you can see both of those radars on the bottom. Of course, we also need solar panels, we need propulsion modules, we need all sorts of other things in the satellite besides the instruments to make sure that it works. But here's why this field campaign is important. The way satellites look at precipitation is different. So we can have a rain gauge on the ground collecting rain, but you have to compare what the satellite is seeing to what we're getting from the ground. And so that's why we have to check these things to make sure that the algorithms, the computer programs that we use to process the data are actually working and that it's matching what we see from space and what we see on the ground. So that's where we need help from scientists and from you junior scientists. Because scientists set up equipment to check that satellite data. Like this is a picture of a ground validation campaign at field in North Carolina. And so with your rain gauge at your school, you're going to help us by contributing data that then we will that then we'll compare not only to satellite data, but also looking at other rain gauge networks nearby. So starting hopefully now, your rain gauge set up at your school, put it into GLOBE. Then what we'll do, we'll have some scientists working with the GPM mission, looking at that data, and helping analyze it, and we'll be putting posts up on the GPM GLOBE community page, and looking also at data from other networks of rain gauges. But of course, it's not really about the scientists just doing the work. We want you guys to be scientists as well. So we'll have opportunities for you to analyze your data, compare it to other places around the GLOBE network, to other sources of data, to satellite data, and really start thinking about how you can do your own analysis. And so just some pictures of different types of data. You might be looking at different sources of data collected by satellites, ground systems, all sorts of things. And really the important thing, I mean, just to remind why this matters, all these different events, we've had rain some places here today in our reporting, our little informal survey. We have hurricanes, we have snowstorms, all this sort of things that can happen. We need to have crops water for planting crops, all these things, and we have to monitor this to be able to understand what's going on. So we need to know how the Earth is changing. NASA is studying that. And, you know, really it's just because precipitation affects us. And we want to monitor the precipitation. So that's kind of, so there's a little bit of, there's kind of my spiel. Measuring snow. Yes, we will. Let's get to some questions. So I am going to stop sharing my screen here. If I can stop share. Okay. So let's see. So we had a question about measuring snow. Yes, you can measure snow. And the way you can measure snow is a snowboard is one way that does a that measures snow. You measure the height of the snow off the ground. But actually, we've got a GPM scientist here, the Dr. Mark Cooley, that actually his specialty is measuring snow. So maybe if you want to talk a little bit about that.
My voice is coming through good. So snowfall is actually really difficult to measure both from space and at the ground. As Kristen said, we actually use glorified rulers, meter sticks, to actually stick in the ground and measure snow. And we just had a big snowstorm here in Madison, Wisconsin, and I went out yesterday and tried to measure snow in 3 different locations that were actually very close to each other, and I got a different measurement at each of those locations. So snow can blow around, it's real light and fluffy, and it's actually, I think, probably the most difficult thing to measure out of anything that falls from the sky.
Okay, so yes, but it's difficult, I guess, is the answer for Nidhi's question there. Definitely. What else? Any other questions? Maybe a couple more questions? I know I wanted to try to keep these to a pretty short time frame, given that you have classes to get back to, but any other questions? Either from the chat or undoing your microphone? So, so that's an interesting question, and we've had a lot of schools express interest. I think we'll really know how many are participating once I start pulling up the data. This week, once I start pulling up and seeing who's entering data in the GLOBE database, so I will be putting that information up. I'll be doing some blog posts about how many schools are participating. But I guess the short answer is I don't really know yet. We've certainly reached out to a lot of schools, but we'll see how many actually are able to contribute data. But as you can see, just here today, we've got at least 10 different locations. I think almost 10 different locations that are participating just this morning. So. Who made the satellite? Excellent question. So the satellite is actually a collaboration between NASA and the Japanese Aerospace Exploration Agency. So they built some of the parts in Japan, they built some of the parts around the US, and then they assembled it all here at NASA Goddard Space Flight Center. So at a building a few buildings over from me. And then they once they had it all assembled, then tested, they actually sent it to Japan to launch. So they launched it from Tanegashima Island in Japan. So lots of different people, I mean, probably several hundred different people worked on the satellite altogether from all over the world. And actually, not even in addition to that, there's the constellation of satellites that, so they built the satellite that they just launched, but then there's also a bunch of other satellites that are sharing data, and those are from even more countries are contributing data using that. So it's really an international mission. Oh, that's a good question. That might be another question for Dr. Cooley. How do you measure hail?
Yeah, so hail is also difficult to measure. We're mostly interested in how large the hail is. We don't usually get enough hail to fall at one point to actually accumulate on the surface, but we're actually more interested in the size of each of the individual hail stones, because large hailstones can cause some pretty big damage. So again, a measuring or a ruler is how we measure it, really.
So yeah, is there a satellite overpass predictor? There are websites that you can go that will show you where the GPM is orbiting and other sorts of things. So I can send those to you. I can make sure that you get that information. Any other questions? How long will GPM fly? I got another good question. The mission is set for 3 to 5 years. So they plan for it at least 3, extension to 5, but they do try to keep, once the satellites are up there, they usually are able to keep the funding for the people to operate them. So, for example, TRMM, the Tropical Rainfall Measuring Mission, that's the mission that kind of the predecessor of GPM, it was launched in 1997, and it's actually still up there. It's getting really close to the end of its life, but it's lasted now almost 17 years. Well, no, more than 17, almost 18 years. So, hopefully a long time, but we'll just have to see. So, Maria, if you can do every day, that would be ideal, but of course we understand that there may be things over weekends or when you don't have school. So I would say as often as possible, you still can enter data. If for 2 or 3 days you can do a multi-day accumulation. So as many days as you are able, but don't worry about it if there are some days that you miss. That's completely understandable. Life happens, schoolwork happens. So as often as you can. Well, excellent. And, for all the teachers out there, you should have my email from your response to the registration. So if you have any questions at all, feel free to get in touch with me. We will have a blog post from Dr. Cooley about measuring snow up later this month. So, yeah. Another good question. No, you should just do it in the integrated one day. There's not a special place for GPM. It's just under the regular GLOBE precipitation data. And what I'm going to do is I'm just going to pull the precipitation data from there. So we didn't make a special place for it. And yes, report to GLOBE, and just in the GLOBE, the regular way you would do data entry in GLOBE. But if you have any problems with that, you can always get in touch with me or the GLOBE help desk if you're having any problems with entering data into GLOBE. Great. Well, I will go ahead and sign off, and we will be doing these webinars throughout the day. So if you have other classes later on that you want to have join in, please join us, and have a wonderful day. Thanks, everybody.